Scientists have discovered water clouds floating in deep space, providing new insights into cosmic water distribution. These clouds were detected in a distant star system, suggesting that water exists in more places than previously thought. Using advanced telescopes, astronomers identified traces of water vapor within a cold, interstellar cloud millions of light-years away. The discovery supports the theory that water is a fundamental component of star-forming regions and planetary systems. Water clouds in deep space may play a crucial role in the formation of habitable planets by delivering essential molecules. This finding raises the possibility that distant exoplanets could have water-rich atmospheres, increasing the likelihood of extraterrestrial life. Scientists believe these interstellar water clouds formed from ancient stellar explosions dispersing hydrogen and oxygen across the cosmos. Unlike Earth's clouds, these spaceborne water clouds exist in extreme conditions, sometimes near absolute zero temperatures. The presence of water in deep space suggests that organic compounds necessary for life may be more widespread than assumed. Researchers detected the water clouds using infrared spectroscopy, which identifies molecular compositions based on light absorption patterns. This breakthrough supports the idea that water molecules can survive even in the harshest cosmic environments. Interstellar water clouds may have contributed to delivering water to early Earth through asteroid and comet impacts. Scientists believe similar clouds could be present in other star systems, shaping planetary atmospheres and hydrological cycles. The discovery also hints that ocean-bearing exoplanets may form in more star systems than once predicted. Water clouds in space are believed to be remnants of ancient interstellar collisions and supernova ejecta. This research provides further evidence that space is not as dry and barren as previously imagined. Scientists are now analyzing whether these water clouds contain other complex molecules essential for life. Some theories suggest that interstellar water clouds could act as reservoirs for future planetary systems. The newly found clouds are thousands of times larger than Earth's atmosphere and exist in deep cosmic voids. This raises the question of whether similar water clouds contributed to the early formation of our solar system. The James Webb Space Telescope played a key role in confirming the presence of water vapor in these distant clouds. These findings may reshape our understanding of how water spreads throughout galaxies over billions of years. Astronomers speculate that such clouds may also exist in other star-forming regions, acting as cosmic nurseries. The presence of water in deep space suggests that liquid water worlds may be more common across the universe. Scientists are considering whether interstellar water clouds could eventually condense into ice, forming comets and icy moons. This discovery strengthens the argument that water is one of the most abundant and essential compounds in space. Some experts believe that these floating water clouds could be linked to the origins of life in the universe. The chemical composition of these clouds matches predictions for how water forms in interstellar environments. If such clouds are widespread, they may influence the development of exoplanets with habitable conditions. This discovery challenges the assumption that water is mostly found on planets and moons, proving it exists in free-floating states. Astronomers now wonder whether similar clouds could provide hydration to young, developing planetary systems. Understanding these water clouds could help scientists predict which exoplanets have the highest chances of sustaining life. Observations suggest that these clouds may be replenished over time through cosmic processes like stellar winds. The presence of water in space clouds could mean that exoplanets form with built-in water resources from the start. These findings could change how scientists model planetary formation and the potential for habitable worlds. Astronomers hope to study these clouds in greater detail to uncover more about their role in cosmic evolution. Some researchers believe that these water clouds could eventually collapse into stars, further distributing water throughout space. The discovery supports the idea that water has existed in space for billions of years, shaping celestial bodies. Further studies aim to determine how these clouds interact with cosmic radiation and other interstellar elements. The presence of water in deep space suggests that molecules critical for life are naturally distributed across the universe. If confirmed in other regions, this finding could have profound implications for the search for alien life. Water clouds floating in space could explain how exoplanets develop atmospheres rich in moisture and clouds. Astronomers plan to investigate whether these interstellar clouds contain additional organic compounds like amino acids. The discovery provides more evidence that life's building blocks may originate from cosmic water reservoirs. These water clouds may even play a role in the creation of icy exoplanets or water-rich moons. Understanding how these clouds form could help scientists trace the origins of water in our own solar system. This research also raises the possibility that moisture-rich exoplanets could be hidden in previously overlooked regions of space. Some scientists think these clouds could be precursors to planets with oceans, given the right conditions. Water clouds in space confirm that water molecules are among the most resilient structures in the universe. NASA and international space agencies are now prioritizing research into interstellar water sources for future missions. This discovery suggests that our galaxy may be teeming with hidden water reserves in its darkest regions. If these water clouds contain additional chemical elements, they could be precursors to life-bearing environments. The study of these clouds may lead to new breakthroughs in understanding the origins of Earth's water supply. Astronomers believe that interstellar water could travel vast distances, eventually seeding new planetary systems. These findings could also help predict how often habitable planets form in different types of galaxies. Further analysis will determine if these clouds interact with cosmic dust to create complex chemical reactions. If water clouds are found in more star systems, it would significantly increase the chances of finding habitable planets. The discovery also challenges traditional models of planetary formation, suggesting water is abundant before planets even exist. Some researchers believe that these clouds could drift for millions of years before condensing into star systems. Astronomers are now looking for more water clouds in other galaxies to see how widespread they really are. The next step is to investigate whether similar clouds exist near known exoplanets with potential for habitability. NASA's upcoming missions may focus on mapping interstellar water sources to aid future space exploration. This discovery provides more evidence that water is deeply embedded in the fabric of our universe. Scientists hope to determine whether these clouds contain enough water to influence entire planetary systems. If these clouds are common, they could provide natural water sources for future space missions. The discovery of deep space water clouds opens new possibilities for understanding how water behaves outside our solar system. Future telescopes may be able to observe the physical processes that sustain these massive interstellar reservoirs. Water's presence in deep space suggests that it may be a fundamental ingredient of all planetary evolution. This breakthrough will likely inspire further exploration into how water moves through galaxies over billions of years. Some experts suggest these clouds could explain the origins of water on early Earth and other rocky planets. As research continues, scientists hope to determine how these interstellar water clouds shape cosmic environments.